In this video, we are going to solve this system of rational equations. And one of the key things to keep in mind when you're solving a system where you're starting off with two or more equations is that in the end, we want ordered pairs for answers. So we're not just looking for a single number like x equals -3. We're looking for an ordered pair like -3 comma 4/5, you know, that type of thing. Alright, so just keep that in mind as we go. The first step will be to set these equations equal to each other. So if we do that, we've got, let's see, x over x plus 5 is equal to, and I'm just going to go ahead and take this negative sign and put it in the numerator, because you can move it wherever you want, top, middle, or bottom. So I choose to put it in the top for convenience. So I'll put that up there. Might as well factor this while we're here, so let's factor this down. X squared can only be x times x. 10, I'm thinking 2 times 5 here. Inner plus outer must equal the middle. To get a positive 3x, we need a negative 2x and a positive 5x. So negative, positive. And a negative times a positive will give us a negative 10. So everything is good. Alright, and then we have plus 5 over x minus 2. Alright, there are many methods for solving equations like this, but the one I've grown to like the most is one where we make all the denominators the same. So I've got an x plus 5. I see this denominator has an x minus 2. So I can put an x minus 2 in the denominator as long as I put an x minus 2 in the numerator as well. So this has both already, so I don't need to put anything up here. Now this has an x minus 2, but it does not have the x plus 5. So I can give it an x plus 5, multiply in the denominator, as long as I multiply by x plus 5 in the numerator. So once you get like denominators, what you can do is cancel the denominators out and make a new equation. So that's what I'm going to do. I'm going to cancel these denominators out. So my new equation will be based on the numerators. So I'm going to go ahead and distribute this though. So I have x squared minus 2x equals negative 25. I have plus 5x plus 25. Interesting. I'm noticing the negative 25 and the positive 25. Those are going to cancel each other out. So now I have x squared minus 2x is equal to 5x. So I am going to subtract 5x from both sides. Whenever I have an x squared and a regular x, I always get 0 on one side like this. So this will give me x squared minus 7x is equal to 0. Now I factor. How do I do that? Well, I think about the first step of factoring is the GCF. So I pull out a common factor of x, and it looks like this. Setting each one of these factors equal to 0. Okay, well this is one solution to the equation, and adding 7 to both sides gives me x equals 7. Now please remember, these are not the final answers. These are just the x values, 0 and 7. Keep that in mind. So I'm going to make a little chart, an XY chart, because I need the y value. So we have 0 and we have 7. but we need the y values that go with these. So where will I get the y value? Well, I could use either one of these equations for y. Of course, I'm going to choose this one because it's relatively simple. So y is equal to x over x plus 5. Now, I can either substitute these values in by hand or I can use a calculator. I'm going to do it both ways so you can see both ways. So say if I put 0 in for x, that would make this 0 over 0 plus 5. 0 plus 5 is 5, so that would make this 0 over 5. Well, 0 divided by 5 is 0. 0 divided by anything is 0, except for 0. So that means I have the point 0, 0. So that's how you would do it by hand, which probably is the simplest way to go for a problem like this. But you know, I said I was going to use a calculator, but I'm just going to keep going by hand. So if I do 7 and then I put 7 plus 5 like this, that gives me 7 over 12, and that's it. That's all I can do. So this is 7, 7 twelfths. So it actually would have been quite silly to use a calculator. But I am going to show you, in case you need it on a more complicated problem in the future. What you would do is you would go to your table and you would type in this function, x over x plus 5, or whatever it may be. So x over x plus 5. If you have that and you put your calculator in Ask X mode, then you can evaluate at any value you want. Now we just did 0 and 7, and we got 0 and 7 twelfths. Alright, so now you know both ways. So anyway, we're looking for these points, 0, 0 and 7, 7 twelfths. So it looks like the answer is B.